To my video on rate of change, or another way of saying rate of change is the slope. So the slope of a line is a rate of change in other words, a ratio describing the vertical change to the horizontal change of the line. And we've already been looking at this when we were writing the ratio of up and over. That was a rate of change. We just weren't calling it rate of change at that point. The slope of a proportional relationship, remember a proportional relationship is a multiplication pattern all the way through. So it means you're multiplying all the x values by a number to get the y values. And this can be determined by finding the unit rate. So the slope of a proportional relationship can be determined by finding the unit rate. That's how much for 1, if you had forgotten what unit rate was. And slope is how steep your line is on a graph. So there's a couple ways that you will hear slope described. And it is change in y over change in x, vertical change over horizontal change, and you will also hear it called rise over run. And the rise describes up and down. And the run describes left and right. Because up and down is described by vertical, and run left and right is described by horizontal. Now, you will also, slope will be represented by the letter m. So we can put m here in parentheses. Okay, now the graph of the line representing a proportional relationship will include the origin. So if it's a proportional relationship, meaning it's a multiplication pattern all the way through, it will go right through the origin. Now, before we go on further and look at examples, I want to look at some and show you some real-life examples of slope. So we know slope is a measure of steepness, so here's some real-life examples. In building roads, one must figure out how steep the road will be. Skiers and snowboarders need to consider the slopes of hills in order to judge the dangers, speeds, etc. When constructing wheelchair ramps, slope is a major consideration because you don't want the wheelchair ramp to be too steep because that will cause the wheelchair to go too fast down the ramp. When building stairs, one must consider the slope of them so they are not too steep to walk on. And finally, in art, the lines drawn must be considered to decide what would be the most aesthetically pleasing to the eye. Okay, and let me just show you a couple pictures, a couple of good examples. Here's an example of a slope here, and the trucks will want to slow down so they don't pick up too much speed. And then we have an example of a circus tent. Now I know it's a little curved, so a roof would probably be a better example because a roof is not curved. And then I want you to look here, the Leaning Tower of Pisa, and then of course certain hills you can see the slope and makes a straight line. Also the ramp. There are all kinds of ramps, but you could do a ramp on a truck. And you don't want the ramp too steep because when you try to get something up the truck, it's just going to keep falling back down. So you want to make sure it's not quite as steep. So those are a couple of examples. So let's go back to our notes here. And look at it, another example. After a shipwreck, Josh is stranded on a desert island. He needs to build a shelter in his first 2 days on the island. Josh cuts down 4 trees. In his first 3 days, he cuts down a total of 6 trees. What is the rate of change, meaning trees per day? So how many trees is he cutting down per day? Complete the table to graph. Okay, so we know that 2 days cuts 4 trees, and I'm sure you all have already figured out how many trees they can cut per day, but let's pretend like we don't know and find the unit rate. So we want to know trees per day. So all we have to do to find a unit rate is to do the trees divided by the days, because it wants to know trees per day. So if the trees come before the per, that goes on top, and the days come after the per, so that goes on the bottom. So 4 trees per day, so for 2 days. And we know that we can simplify that by dividing top and bottom by 2. So it's 2 trees for 1 day, okay? And a unit rate is how much for 1, so 2 trees per 1 day. So we can simplify 2 divided by 1 into 2. So we can say 2 trees per day. Okay, now we can go ahead and, if we know it's 2 trees per 1 day, that means how much for 1 day, so we can fill this in as 2. We know if there's 0 days, then they're not going to make any trees. And then in the original problem, it said 3 days, cut down 6 trees, and then 4 days, how many trees do you think they would cut down? Good, 8. So we can graph that, 0, 0 right here. 1, 2 would be right here. 2, 4 would be right here. 3, 6 would be right here. And 4, 8 would be right here. If you have a ruler, now would be a good time to get that out. You can pause the video if you need to get one. And we're going to connect the points. Now, notice I didn't put arrows on both ends because I'm not going in this direction, because you can't have negative trees or negative days. But I can go on and on this way if I wanted to know 5 days or 6 days, etc., etc. Now, the rate of change, also known as the slope, also known as change in y over change in x, also known as vertical change over horizontal change, also known as rise over run. So we can use all those terms. But the rate of change, we can look at the graph and figure out that we went up 2 over 1. So we rose 2 and we ran 1. So that's a 2 to 1 ratio. And the trees is the 2 and the days is the 1. So we're going to say 2 trees over 1 day. Okay, and we can simplify 2 over 1 to 2, so we can also say that the rate of change is 2 trees per day. Now, the slope can simply be found by picking any 2 points on this line and finding the rise over the run, or the vertical over the horizontal, or the change in y over the change in x. So I can go up 2 over 1. So up 2 over 1, and 2 divided by 1 is 2, so we say that this has a slope of 2. So we know he can cut down 2 trees per day. That's the unit rate and the rate of change. And notice how all these values are equal because they all mean the same thing. Okay, moving on to the next example. So it says Taylor bought 2 king-size candy bars at the store for $5. Another day, she bought 3 king-size candy bars for $7.50. What is the rate of change? Cost per candy bar. Complete the table and graph. So we know that 2 candy bars cost $5. And I know you've probably already figured out the unit rate. But we're going to pretend like we don't know it. So we have $5 because we want to know cost per candy bar. So we're going to put the cost on top and the candy bar on the bottom. So $5 for 2 candy bars. So we'll call it candy bars. Now, we've got to figure out how much for 1. So we could divide top and bottom by 2. And we find that we have 2.5 over 1, which is just 2.5. So we have $2.50. So the unit rate would be $2.50 per candy bar. So every candy bar costs $2.50. Now we also know that 3 candy bars cost $7.50. And now we know how much 1 candy bar costs. It costs $2.50. We know that 0 candy bars will cost nothing. Can we figure out how many 4 candy bars is? $10. Now I'll show you how we could have figured out that 4 candy bars was $10 without, if we couldn't figure that out. So I'll show you when I'm graphing. Now go ahead and make these darker. Let's go ahead and call this, let's put it out here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because it's very difficult to see there. And we're going to start with 0, 0. Okay, 1 candy bar costs $2.50, so right between the 2 and the 3 would be $2.50. 2 candy bars cost $5. Okay, 3 candy bars cost $7.50. So what we could do if we didn't know that 4 candy bars was $10, we could go up 2.5 over 1. So it's going to be hard for you to tell this, but that's 1, and that's 2.5 over here. For my rise is 2.5, and my run is 1. And then we could go up 2.5 over 1, up 2.5 over 1, up 1/2 and 2 more over 1, and then we could find that 4 candy bars was $10. Okay, so go ahead and connect these points. And now we're going to talk about the rate of change and the slope when we're looking at the graph here, and then we'll go ahead and write it on the line. So we know that we can go up 2.5 over 1. So the rate of change is going to be $2.50 per candy bar, just like the unit rate. Now with the slope, there's a couple different things I can look at. I can go up 2.5 over 1, but a lot of times I don't always write my slope as a decimal, okay? So 2.5, so I could look at the next 2 points, so this point up 5 over 2, and I could call that 5/2. So that's what I'm going to show you when we write our slope. So our rate of change here, we saw that we went up $2.50 and over 1 candy bar, CB. And then that 250 divided by 1 is $2.50 per candy bar. And then the slope, we had a point here. You already have these points here, but let me show you again. And we said up 2.5 over 1, but if I wanted to write it as a fraction, because I didn't see 2.5 as a choice, I could go up 5 over 2. And then I could get 5 over 2, or I could also represent it as 2.5. Okay, but normally you're going to represent your slope as a fraction, because when we start graphing slope, you're going to need a rise and a run. A 2.5, a decimal isn't going to do us any good when we start graphing these. Okay, turn the page. And now we're going to look at some examples that aren't real life examples. So I'm going to show you a way we can find the rate of change without looking at the graph. So we said that rate of change, or slope, is change in y over change in x, vertical change over horizontal change, and rise over run. So we can look at what's happening to the y's. So let's look at the y's. From here to here, notice it went up 2. From -2 to 0, it went up 2. From 0 to 2, it went up 2. Now, when I look at the x's, this went up 1. This went up 1. And 0 to 1 went up 1. So let's look at the ratios. Notice they're all the same. Okay? 2 to 1, 2 to 1, 2 to 1. So the ratio of y to x is 2 over 1. Now, can that be simplified to a whole number? It sure can. So we say that the rate of change is 2. And since slope means the same thing as rate of change, we also call it 2. And notice I put an m in because slope is represented as m equals 2. So instead of writing out slope, sometimes we write m equals 2, and it means the same thing as slope. It's just the letter that represents slope. So let's look at example number 4. Okay, let's look at the pattern of the y's compared to the pattern of the x's. So from -6 to 0, I went up 6. From 0 to 3, I went up 3. And from 3 to 6, I went up 3. Now let's look at the pattern of the x's. -4 to 0, I went up 4. 0 to 2, I went up 2. And 2 to 4, I went up 2. So it looks like I'm going to circle this one, and I'm going to circle this one. I didn't circle the last one because it's the same as this one. So we have a 6 to 4 ratio. Now let's simplify that to make sure all my ratios are the same, because they need to be, otherwise I made a mistake. 6 divided by 2 is 3. And 4 divided by 2 is 2. So that makes a 3 to 2 ratio. Notice this makes a 3 to 2 ratio, and this makes a 3 to 2 ratio. So the rate of change is 3 over 2. And since we're not doing a real-life example, I can actually leave it 3 over 2. I could also say that this is 1.5 as well. And here, the slope is 3 over 2. And the slope could also be called 1.5. But if I have a fraction here, and it's not a real life example, I want to try to write the fraction if at all possible. Okay, number 5. Now this is a horizontal table. It's still the same idea. So we're going to find the pattern of the y's first. 51 to 85. Now if you can't figure out the change here, you can always subtract those if you can't find the change in your head. But that is went up 34. And again, you could subtract them if you didn't know that this went up 17. And again, plus 34. Now the top is much easier to see the pattern. 3 to 5 is plus 2. 5 to 6 is plus 1. And 6 to 8 is plus 2. Now I'm going to circle these two because these are the only two that I see. This one is the same as the last one, so I don't need to circle it. So we got 34 over 2. Remember, we're putting the y over the x, and I simplify that by dividing top and bottom by 2. So we have a 17 to 1 ratio. This is a 17-to-1 ratio, so I know they're all equal. And 17 divided by 1 is 17. So I know my rate of change is 17, and my slope is also 17. Okay, let's look at one more example. Okay, now we're dealing with decimals here. So again, if you can't see the pattern from 8.1 to 10.8, you could just subtract the 2. But I know that we're adding 2.7. And 10.8 to 16.2, I know we're adding 5.4. And here to here, we're adding 2.7. Now the top is much easier to see. Plus 1, plus 2, and plus 1. Now, let's look at the ratios. And I see two different ratios here and here. So I have 2.7 over 1. Okay, and I know that that's going to equal 2.7. And I also have 5.4 over 2. So I could divide top and bottom by 2 because this isn't a fraction like 3 over 2. We have a decimal in here. So I could go here, divide by 2, and I get 2.7 over 1, which is just 2.7. So sometimes you might see a rate of change is a decimal. And then, of course, the slope is the same as the rate of change. So it's also 2.7. Now, you could change this to a mixed number and change it to an improper fraction. But just know if you see the decimal and they're all listed as fractions, you can convert them back and forth. So that concludes our notes on rate of change and slope. I hope you have a great day.